Hello, my name is Mario Martinez and welcome to this second tutorial on ABB Robot Studio. In this tutorial, we're going to continue with the previous one, from where we left from the previous tutorial, where we basically developed this setup. We started with a robot. In this case, was the IRB 120. We made some PCR fixtures, and we basically started doing like this kind of simulation where it goes from one to another, like these vials, because these are like small vials that we have there, and just try to simulate or kind of simulating this this process of picking and placing, or picking and placing things from one and deliver it to another. We also started doing the inside the Rapid software, inside the Rapid, we started doing like more advanced stuff, like using whiles, using offsets, and using new functions as well, and defining new functions inside the Rapid code. So in today's lesson, as stated before, we're gonna start making some inputs into our controller, because we don't see it in here, but this robot is connected to our controller, and in the controller you have inputs and outputs, or you can actually connect some communication devices. Like if we remember from the previous tutorial, we connected a Profibus device, to allow us to connect to other devices. So we can simulate that in here as well. Like for example, here, the first thing that I'm going to be doing is I'm going to go to the controller tab, and in here in controller tab, you see you have a lot of options. We're going to go with the options of we're going to go to configuration here. And in here in configuration, we're going to go to input-output system. And you can see that we have a lot of inputs and outputs. Most of them, they are already, like for example, a lot of them, they are already used. And you can, for example, for this robot, you have things that are already used. We cannot change those. But some robots, not this one, but some other robots, will have some inputs and outputs. We'll have like a small controller with a lot of inputs and outputs that you can use. For this case, instead of doing that, we use the Profinet device, because it doesn't have any inputs and outputs. And we're going to create some signals, some input signals or output signals from this controller. So we're going to go again, configuration, input output system. You go here, and then you go into the signal here in the left tab. You click signals here, signal. Not this one, it's taking a while. There you go. And we're going to create a new signal. In this case, we're going to right click on it, new signal, and a pop-up window will appear. And in here, where we're going to create, let's for example do a digital input. I always try to call it like that, DI. And we can put it user start. That's the name. And we're gonna, what type of signal it is, like for example, analog input, analog output, digital input, digital output, group input or group output. Those are like all means of communication. Actually, some people still use them, because instead of activating just one digital input or one digital signal, just one port, instead of activating one, you activate a group of ports, or you expect a group of ports to be activated. This was used in old times, especially when there was or where you don't have any networks. Some of them are still used today, because sometimes you don't have networks. So some people basically, instead of using a network device, they just output a bunch of ones and zeros in the pins, and with that you send codes to other machines, or to other robotic manipulators, or to other PLC systems, so that they can communicate. So that's why instead of sending one bit, you send a bunch of bits with different codes, yeah, to try to communicate amongst them. So that's why you have group inputs and group outputs. But in this case, we're not going to do that. In this case, we are simulating that we have a network device, which is a Profinet device. So I'm just going to leave it in digital input. Of course, like I said before, if you have inputs and outputs in here that you can actually use, like are for the end user, you will see them, like for example, in other type of robot with other type of robots. Like for example, if you select these ones, the IRB 1010 or the new IRB 1090 or these ones, they do have some digital inputs or digital outputs that you can actually use. But in this case, because this doesn't have, we have to add this communication system, this Profinet communication device. But in the ones that you can use, you will have it in here. You will have it general input, GPIO, general input and output. You can actually select it, right click on it, and you can in here edit the signal, and it will allow you to edit the signal. In this case, it doesn't allow you to edit anything because they are already used. So we have to create new ones. So new signal again, the pop-up, it was digital input. Let's say like a user start. The type of signal, let's put a digital input like this. We're going to assign it to a device. In this case is the PN internal device, which is basically the Profinet the Profinet device that we are using. So we're going to assign it to that. We can make a label, basically some description. Yeah, I can in here put like user start button. Device mapping, because it's configured with a device, you are configured. We can leave it in blank actually, and there is no problem. Nothing's going to happen. But in reality, we actually use devices, so we can configure the device. We can configure the Profinet device to be connected to our machine. And in here in the device mapping, like okay, which port or which address am I using? So in this case, let's put an address. We can, this is simulation only, so we can put a name to the address. If we don't put anything, don't worry, you can leave it in blank and it's the same. Yeah, and in here in access level, this is something like we have to be careful about, because if the input is going towards the robot, like to the robot, yeah, you can leave it as default. Yeah, if the input or the output goes to the robot, like for example, you are simulating, we are going to simulate a button, yeah, like a regular push button. Let's say that push button is connected to this Profibus or Profinet device. Somehow it's connected to that, and we're going to read it in the port 128. Yeah, but in this case, because it goes to the robot, we can leave it as default. But for example, if we want our digital input or digital output to modify something, and we're going to see this in the next tutorial, but if we want our digital input or digital output to modify something from our simulation that is not part of the robot, like for example, maybe I make a digital output here that, okay, whenever you run this part of the code, the conveyor moves. A simulated conveyor, we're going to see how to simulate a conveyor in the next tutorial. A simulated conveyor, I want it to move. So if I want to do that, because I am affecting not the robot per se, but something in the simulation, I have to go default in here access level all, so that all the components in the simulation have access to this input or to this output. In this case, because I just want the robot to have access to this input or to this output, I can leave it as default. But if I want some other things, or to activate some other things, or also, for example, another example will be the gripper. The gripper is not part of the robot. The gripper is something separate from the robot. So if I want to activate the gripper, I need to put access level to all, because the gripper is a separate thing from the robot itself. So I'm going to use a digital output from the robot to activate the gripper. In this case, I'm going to leave it as default. Yeah, because this is a digital input to the robot, so it's not a problem. And I'm going to just press OK. And when I press OK, you will see this. These changes will not take effect until the controller is restarted. And okay, don't worry, we can press OK. It always this pop-up always shows, and it's because we need to restart. In here, this is the button of restart, so that the controller can update all the inputs and outputs that the controller has. So we have to restart the controller. For this case, we're just going to leave this digital input user start. And now what we're going to do is we're going to restart our controller. We're going to click in here restart, because now we have defined it a digital input. We're going to restart the controller. One restart, we press OK. You can see the controller is updating all the variables and all the new inputs that it has. Now it's restarted. And now we can go to our rapid program. Here it is, the rapid program. And let's put in here, before the while, let's remember in our program, the first thing that we do is we go home, we go to the position home. Then let's put in here a wait function. You can wait for different things. In this case, we're going to wait for a digital input, wait di space. What type of digital input? In this case, remember, we define, here it is, define user start. This is the digital input that we have. And we're going to wait for this to be high, which the value that we're waiting for. And that's it, semicolon. So now what's going to happen is going to go home and it's going to wait until I click or until I press this button, and it's going to start the program. Okay, so now we oops, there you go. So we apply all, and then we synchronize to the station, synchronize everything. Okay, and then we go to simulation. But before hitting play, or we're gonna go to the input output simulator. We're clicking here, and in here we can see all the inputs and all the outputs that we currently have. So in this case, we're gonna go to the what do we want? We want the digital inputs, and you can see we have here the user start digital inputs. If you don't know, you can filter them via by the device. So for example, here you have the internal device. So in the internal device, you can check, because this is a range. Remember that we put it in the 128. So you see how many inputs do we have in that device. So you can select any input that you want. So here it is. Here's the input, the user start input. You can click on it. You can put it to 1 to 0. So we're going to start the simulation. And it's going to go home, and it's waiting, and it's going to continue waiting until I press 1 in here. And if I press it, it's going to start the simulation now. There you go. It's going to go into the while function. I'm going to press stop to stop the simulation. First of all, I'm going to reset this button. I'm going to press stop. Now, for the next part, what I'm going to do is I'm going to do a setup of some digital outputs. So in the same part, we go to signal here, new signal. And in here in new signal, let's put now a digital output. Digital output stop. Okay. Stop light or something like that. You can call it however you want. Yeah, or program stop. Yeah, I'm going to put program stop. Program stop. Type of signal, digital output. I'm going to assign it to the same to the internal device. Let's imagine that we are, if the program stops, or if the program hasn't run yet, we're going to just send this to another, I don't know, maybe a turret or something, some LEDs, or maybe a PLC, whatever we want. And here I'm going to put stop signal. Digital output stop signal. I'm gonna map it to, I don't know, let's put it 129, just to continue with the numbers. Access level, do I need someone else to verify this? Like, for example, am I using it for a conveyor, or a conveyor is going to start if this signal is on, or am I doing something in this case? No, actually no. I just want to turn it on. Yeah, nothing else. So I'm just going to leave it like that. Yeah. And okay, I press OK. I'm going to make another digital output. Yes, I know it's not going to take effect until the next one. New signal, the same. Digital output. Program, let's put it idle. So I'm just waiting. Digital output. Let's assign it to the same device. 130. I'm sorry, 130, the device mapping. Identification. Digital output when the program is idle or is waiting for something. The same default as well. There you go. And I'm gonna make a last one. In this case, I'm gonna call it digital output. Program running. Type of signal, the same, digital output, the same device. Digital output program is running. You don't have to fill out this identification label. You don't have to. It's just some information. Device mapping, let's do 131. Yeah, okay. Now we have all our digital outputs. Yeah, and a digital input. We're going to restart this. Let's restart. There you go. As you can see here, now I have outputs in my controller signals. I haven't removed this part, but now you have inputs and you have outputs in there. And now I can use this digital output inside my rapid code. So for example, in my main, I can go to my main. And for example, maybe I can put here a wait function. Wait, just wait some time. I don't know, in seconds. Let's wait around 5 seconds just to put a number. And before this, I'm gonna set my digital output. Which digital output? Digital output program stopped. I'm gonna set it to 1. I'm gonna then go to home, and when I arrive home, I'm gonna put it to 0. And I'm gonna set my digital output. I'm gonna set another digital output. Digital output program idle to 1. And when I start the program, when I'm gonna wait for the button of the user to turn on the button, then in here I can set it to 0 because now it's not idle anymore. And I'm gonna set digital output program running to 1. And once I finish, I'm gonna set program running to 0. And I'm gonna put the digital output to stop after we get home. And there you go. Basically, I'm controlling this depending on my on the movements that I have. Of course, I will. There are many rows and columns. Maybe I can put maybe less rows and columns in the next simulation. But for now, I'm just gonna apply the changes, then synchronize to the station. I'm gonna send all this to my station. Okay. And then I go into my simulation and I can start my simulation now. I can start, and as you can see, it's stop. It's going to be for 5 seconds. And then it's program idle, and it doesn't move because it started at home position, so that's why it didn't move. So it's going to be in idle until I start this, in which case the program is going to be running. And when the program finishes running, it's going to go to stop again. So this is how we simulate outputs and inputs in our code. I can run it again if you want, so that you can see. So you can see, like, if I press play, it's going to be stop. Then it's going to move to the home position, and it's going to get idle. And then I can press start, and it's going to go to run. So imagine this, instead of three simple outputs in here, this can be like a turret. You know, the ones that are green, yellow, and red, and they are on top of, for security reasons, on top of things. So they can turn on or off a turret. So this is how we set up inputs and outputs. I'm going to stop it. A more cleaner way, or a cleaner way to program these set digital output pins, especially if they are for, making some announcement like a turret or something, or maybe turning on some some LEDs or something. What I will do is I will put them as a subroutine to make sure, like, for example, process set status, I don't know, idle, something like that. And then in here, I will set the digital output program idle as 1, and the rest of them, like program stopped and program running, to 0. I'm just going to change this to 0. And then I can just end the process. And there you go. I can just copy paste this and just change the name of the function. So set status, I don't know, running. And I put a one in run, 0, 0. And set status, instead of running, maybe stopped. And I put a 1 in stop. I can also make other type of configurations, like, for example, instead of stop, if I have an issue, maybe let's say there is an issue, so I put here issue. So maybe it's a stop and idle 1, 1. So that this is a code for a type of issue or something. Yeah. So I can control all this, and instead of putting this like set digital output and all this digital outputs here and all these things, I can just call the functions set underscore status stopped, and then in here set status idle, and finally set status running. Yeah, and now it's becoming a bit cleaner, my program. There are other ways, of course, of making this clearer. This is just one of the simplest ones. This is just to show you that I can turn on and off these digital outputs, or set on and off these digital outputs. In here I can put set status that's running in there, and this is there you go. Something like that. I can just go to rapid, apply all, synchronize to station, synchronize everything, and I can just go to simulation and it's gonna be exactly the same. This is stop in 5 seconds. It's gonna go to idle, and now it's running. It's because I left the user start button pressed. You have to be careful because this value is if I click it, it stores the value. So that's why it started since the very beginning. So if I go do play again, it's a stop. In 5 seconds, it's gonna go home and start idle. There you go. And now I can press this button and start the simulation. I'm going to stop it. Now what I'm going to be doing is I'm going to create another input, and stop input or a stop input. To this, I'm going to go again to configuration, input output system. I'm going to create here in signal a new signal, which is going to be digital input user stop. Type of signal is going to be a digital input. I'm going to assign it to the same device. Digital input stop button user. I'm going to put it in 132. There you go. Still default the access level. Okay. And now, using this stop button, I'm going to restart this. Okay. Let's imagine for a second that this stop button is a push button. So it's a push button. Instead of keeping the number like this, it's actually a push button. Basically, you just push it once, and this one only remains for almost nothing. Yeah. So what do I need to do? I need to use, well, naturally we can use for this type of signals that are, because imagine if this is a push button, this is a regular button. So I can just keep it, it's going to be kept pressed. If I just press it once, it's going to keep 1 forever. And when I press again, it's going to go to 0. But let's imagine that for the stop button, if I press it, in this case, I cannot simulate push buttons in here. But what I can do is try to simulate, like, okay, I do it very fast, the 1 and the 0. So just for the sake of this simulation, let's imagine that the stop button is a push button, a normally open push button. And what I'm going to do is I'm going to stop my simulation if my stop button is pressed. To do that, and this is because of, I just want to show you about how to use interrupts in the program. Yeah. So to use an interrupt, the first thing that we have to do is we need first to declare an interrupt handler, or basically it's an interrupt numeric variable, or interrupt number variable. It's called like that. In this case, I'm going to define it in here. So it's going to be before the main, a type of variable, interrupt number, which is handler of the interrupt. I'm going to call it di stop. So basically, this is not an interrupt itself. Actually, it's like a reference. It's a reference to manage the interrupt. That's why it's called a handler. And basically, it holds the interrupt connection. Yeah, so that's why we call it the handler of the interrupt, or the reference to the interrupt. So the next thing that we have to do is inside, we have to delete. We have to verify if this handler is not connected to another interrupt, because sometimes we forget, or sometimes we forget that maybe we already used this handler for another interrupt, or is connected to another interrupt. So in this case, this is a best practice, always always delete if there is a previous interrupt connected to this handler. And now we're gonna connect this interrupt handler with, we're gonna connect this, and we're gonna set a function. I'm gonna call this function trap stop DI. So we're gonna connect this handler with this function and interrupt signal digital input. So I'm gonna receive the digital input from, because like you can see, if I just press I, interrupt signal, you can put it from a digital input, from a digital output. You can receive the signal from whatever you want. In this case, I'm gonna select it from the button user stop. So if the button user stop changes to 1, call the handler DI stop, and the handler DI stop will immediately call this function, which is an interrupt service routine called trap stop digital input. Interrupt function or interrupts, they use a different type of function, not like the ones that you see here, that process function or end process function. They use a function called an interrupt service routine, or ISR, which in this case, or in rapid, we have to set them with a different name. It's not a process. Actually, I'm gonna set it in here, maybe. We call it trap. So trap is the function, or the interrupt service, the interrupt function, or that whenever something is detected in here, it will immediately call this function. So I'm just defining the interrupt service routine, or the callback function of the interrupt. In here, I'm in this case, I called it trap stop DI. And in here, usually inside trap functions or inside callback functions or these service routines, what we do is a very simple code. As you can see, it doesn't allow us to bring any parameters whatsoever, so there is no parameters in here. So the only thing that I can do is small pieces of code. Try to make it as fast as possible, because you don't want to waste time in these callback functions, because remember, it's going to stop the program, go there, do something, and then go back to the program. So in this case, I'm just going to set up a variable. In this case, stop require variable. I'm going to set it to true. So it's something like very fast. There you go. Now I'm going to declare this variable as a global variable. I'm going to declare it here outside the main. So I'm going to declare it as a persistent variable. Why a persistent variable? Because a Boolean, by the way, is also a Boolean. It's not a number. It's going to be a Boolean variable, because true or false. Stop required. And in here, I'm going to define it as true. So what am I doing in here? Basically, is I am creating this variable as a persistent variable. Yeah, and what is a persistent variable? Like, even if we have some troubles, or if this is shut down, these variables do not get erased from memory. So they are retained in memory. For example, if there is some sort of shutdown or power off, or whatever happens to the machine, these variables are retained in memory. So they are really good for certain processes. We have to be careful not to use not to use many of them, yeah, but they are really, really good for this type of purposes. So if we want a variable that if we have an issue with the power or something, it keeps the last value like forever or until you change this. Yeah, so this value is gonna be kept until you change the value, or in case we have some issues. Yeah, so usually these type of variables are used for calibration things, user settings, cycle counters, etc. Yeah, so those are the main usages of this variable. Which, by the way, I just realized I put true here is false. Yeah, because I want my variable to initialize as false, and then I will change it inside the interrupt. So now we have configured the interrupt. So I will repeat the steps very quickly. I define a handler or a variable, this interrupt, the numeric reference to the interrupt. In this case, di stop is a handler. I defined a persistent variable because it's good to know that there exist other type of variables, and that even if something happens to the program, the value of this variable will be kept forever, which is really good. Now the first thing that we do is delete. I delete the handler. So basically, if this handler has some other interrupt connected or attached to it, what I'm saying here is forget about the previous attachment to this handler. We're gonna connect a new connect this handler with this function, with this trap function, or with this callback function, yeah, or interrupt service routine. And then whenever we receive the interrupt signal will be the user stop button when I receive a 1, and it's gonna immediately call my handler for that. So now that I have done this, I can just inside my while loop, I can make an if stop require, then exit end if. And now what I'm doing is I am putting my stop requirement at the very top of the program. So I will verify for this variable, check if it's true or not, and if it is, I will immediately exit this. If not, I will do the program, and then I will check again in the next iteration. And that's it. This is how I manage an interrupt inside my program. This is just the configuration. This is the handler and the variable that I'm going to be using. And in here, the interrupt service routine or callback function is defined there. It's more or less the same as any microcontroller, if you have used microcontrollers before. Then I'm just going to apply all, synchronize to station, synchronize everything. Okay. There you go. I go to simulation, I press play. And as you can see, it's stop. Then my program is going to go to idle. There you go. And it's going to stay there until I press start. And when I press start, my program is going to run. But when I press stop, because remember, this is a push button, so I'm going to just press it like really quickly. Like, okay, 1, 2. The program actually stops. Yeah. And it's finished. Now the program actually totally stops the program. Okay, so that's it with this on how to manage interrupts in this tutorial, and how to manage digital inputs and digital outputs. Yeah, the next thing to do will be to add some other digital inputs and outputs, such as a button to pause the simulation or to pause the movement, because we already have the start button, the stop button. We have three digital outputs. Yeah, and Some other things that I will do will be like, for example, let me see if I have it. I'm gonna. So I have another project for you. Like this is the exact same project as the one we did, as the one before. But in this project, I just upgraded, or this is the version 2 of my code, of the code that I just showed you. But in here, like if you can see this, I made a finite state machine to control all these starts, stops, initialize, and collect, deliver things. It's the exact same problem. I just made a state machine. So instead of, you can see that I still have the same offsets. I still have the same the offset of the wells, or of the vials. Yeah. But I created different like buttons, like stop, pause, start, and reset. Yeah, so I created 4 different buttons. I created the same status signals in here. In fact, I don't know if I can get a bit closer. Oh, there you go. I can get a bit closer. Yeah, I created some more states and some more variables, with because now I have 4 buttons, and I realized, okay, these 4 buttons are going to be push buttons. And what I did, it looks very large, but actually it's quite easy, because at the end of the day, what I did is it's a state machine. So inside my while loop, I put my first state, which is idle. So I'm going to start in this state, and I'm going to check if there is a stop pressed, check if there is a pause press, or if the reset button is pressed, or if the start button is pressed. And for each one, like for example, if the start button is pressed, do this. If the reset button is pressed, do this. If the pause button is pressed, do this. Or if the stop button is pressed, do this. So it's a lot of if and else. Yeah. And each one gets me to the next state. Like for example, if nothing is, if it's in the idle part, so basically not doing anything, just waiting. Yeah. And if I press start and I don't press any other button, if I press start, I immediately go to the initialize state, or to the init state. So in the init state, I can go all this way here to the init state, and I'm going to go to the initial position, to the init position. Yeah. And if there is nothing else pressed, if nothing is pressed, like no pause, no stop buttons or anything pressed, go to the blue collect. So collection of the blue. So go to the blue one and start doing the cycle. Go to the blue one. And if nothing is pressed in here, if there is no pause or stop button press, go to the deliver one. And in the deliver one, go to the next vial or next well section. And in the next well, basically is check if I have finished, or if I haven't finished. Go again to the blue collect, and red deliver. Yeah, and so on and so forth. But if I press pause, for example, I immediately go to the state idle again. If I press pause in any of the states, if I press pause, I go to the idle state, and in here in the idle state, I start waiting. I wait. Yeah, and if someone presses stop, I totally stop the program and I reset all the variables. And if no one presses stop, maybe it will press start again and it will continue where it left off. So that's why I always remember the state that I am in and the previous state that I was. So if someone press the pause button, I can go back to the state that I was and repeat again the same state. So it's just a basic state machine, really, really basic, inside this while loop, inside this big while loop. And I always prioritize things. Like, for example, every time I go into the while section, I do the check first the stop, then check for pauses, then check for resets. And if nothing happens, then check for start button. Yeah, because you can be in pause and maybe reset everything manually, or maybe you can be in pause and stop then everything, or you can be in pause, or you can be idle, or in the pause state, and suddenly you can press start again and it has to restart where you left off. So this is a very simple state machine. You can look at it with more with more time. It's not that difficult. The only thing is that it's exactly the same what we have been doing, just with the state machine in there. So I will leave this as an example. Yeah, I will call this project 2, and I will leave it to you there as an example. And it works. You can just simulate it when you receive it, and you can simulate it, and you can actually see the inputs and outputs. And I think for the inputs and outputs, they are in the same in the PM internal device. You can see them. You have user stop, user start, user pause, and user reset. So you can start in here, and the movement is gonna start. Oh, by the way, I need to go to the simulation part, and it's gonna start the whole state machine. You can pause it in here. Like for example, if I click pause, it pauses the movement. Yeah, and if I click start again, it starts the movement again. Yeah, you can also stop it if you want, and it's gonna go back to the stop position. So you can check all this, in your own time. I'm gonna leave it to you as an example of how to implement a state machine. Okay, so that's it for today. Thank you for coming. And see you in the next tutorial.